Now that we've really quickly reviewed addition, subtraction, multiplication, division, exponents, our basic operations, how do we deal with cases where there's several operations? What is the order we're supposed to do them? What do we do first? Which operation? And that's where PEMDAS, or order of operations, come in. PEMDAS stands for parentheses, exponents, multiplication, division, addition, subtraction. Students are often taught to think of that as please excuse my dear Aunt Sally to help them remember. PEMDAS. Please excuse my dear Aunt Sally. And that essentially says, do your operations left to right, but give priority to the first elements in PEMDAS. Parentheses first, exponents second, etc. So, if that is our rules of the road of how to work through operations from first to last, let's take a quick look at that in an example. What is 30 divided by 2 times 5? In this case, we have no parentheses. That would be our first step. Working left to right, we would go 30 divided by 2. We could suggest that's 15. Multiplied by 5 equals 75. But wait a second. I did division before multiplication, and PEMDAS has M before the D. Well, doesn't that suggest I should really be doing 2 times 5 first, my multiplication, which is 10, and then do my division, which in this case it would be 30 divided by doing my multiplication first, 10. And 30 divided by 10 equals 3. So which is the correct answer? Is it 3 or is it 75? We have to be careful about PEMDAS. Really, what PEMDAS says is do multiplication and division at the same priority, working left to right. So if division is left of multiplication, and it is in this case, we would do that first, which means we really do the 30 divided by 2 to get to 15 first. And likewise, addition and subtraction are essentially the same level of order in PEMDAS. So be careful. When you look at PEMDAS, don't think it literally is PE, then M, then D, then A, then S. Multiplication and division need to be treated at the same priority, and addition and subtraction need to be treated as the same priority. If you do that, you would have come to the correct answer of 75 in our equation. PEMDAS is the way students have been taught order of operations for decades. It's the way I was taught as a child. Despite that, there is controversy currently surrounding PEMDAS and its accuracy. So what is at the heart of the controversy around PEMDAS? Is it wrong? What my tutor and my teacher have taught me for years, is that not correct? A smart student might take a look at this and say, teacher, parentheses is not really an operation. Parentheses is just a grouping. It's not addition, it's not subtraction, multiplication or division. It's not an operation. So why is it included in a rule of order of operations? Very good point. And another student might raise his hand and say, we just learned subtraction is essentially addition of a negative number, so addition is a function of subtraction. They're the same for order of operations. And that, of course, is the nuance we need to be careful of in our last problem. And the student might say, well, you also just taught me division is really multiplication of the reciprocal. So those two are essentially the same. Which leads to something you might have heard recently is called a boss triangle as an alternative to PEMDAS in order of operations. And essentially that is a triangle that says we do exponents at the top, we do multiplication, division equally in the middle, and we do subtraction and addition equally at the bottom. And note, there is no P for parentheses in the boss triangle. Well, that really is essentially correct. Can't argue with the student there, and that's why the boss triangle was created. However, another clever student might look and say, well, you also just taught me addition really is the same as multiplication. If I had 3 times apples, that would be the same as adding 3 apples together. Apple plus apple plus apple. So if addition and multiplication are really the same, and we know addition, subtraction, multiplication, division, as we just discussed, are the same, then why is there any differentiation between any of them? Addition, subtraction, multiplication, or division? Oh, that's also a very good point. And taking it another step further, exponents, as we just reviewed, is really defined by multiplication. So aren't they really the same? If I had an apple squared, that's just the same as an apple times an apple. So why should exponents come before multiplication and likewise division, addition, subtraction? In essence, the argument says, essentially, all we're really doing is going left to right, and we're grouping. The operations themselves are fundamentally the same, and PEMDAS, therefore, really should not be used. So, what do you think? That is a valid point there, and that is the essence of the controversy. And it is correct, but you know what? I think, in practice, we'll give poor Aunt Sally a break. At the end of the day, PEMDAS still works, practically. You can argue that, yes, P's a parentheses, it's not in operations. But if you appropriately order your multiplication, division together and your addition, subtraction together, working left to right, as a practical answer, PEMDAS will give you the right solution. In other words, PEMDAS works. So let's give dear old Aunt Sally a break. And also, I think it's worthwhile to point out that the order of operations is really a man-made convention. It is a rule put in place for us to understand the same language. As we began part A of this section discussing, we are going to make sure we're all speaking the same language. It is not a greater eternal truth. There is no fundamental universal law of math that says the order of operations have to be this way. It could be any way we define it to be. And that's essentially all we're doing. So if used properly, PEMDAS should give you the correct order of operations. Next, we'll look at the associative, commutative, and distributive properties and how they relate to operations.